vessel, utensils.
I think we can start. So good evening, everyone. Hoping you all are doing great. Thank you so much for joining our first webinar. So before starting, I would love to introduce further about RoboVice. So RoboVice is a robotics organization, and our tagline is an organization by beginners for beginners. I think somebody is on unmuted. Just mute yourself. It's actually echoing. So yeah. More about RoboVice. So RoboVice, we have started the organization last year in October 2021, and we have started our services only this month, actually in February. We have started uploading content on our social media handles. So we aim to help students master their skills in the field of robotics, to help them get expert guidance on doing projects. And our initial goals include uploading quality content on social media handles on our social media handles, and also conducting free webinars like this one. So thank you all for joining. We'll be shortly starting, to everyone who joined now. We are so grateful to have all of you. And more about RoboViz, our future goals include having massive open online courses where students can learn from the basics of robotics, and also to establish a strong robotics community. Those are major future goals, and we are planning on others too. So once again, thank you everyone for joining. So before starting the session, I would love to introduce my team as well. So first of all, let me introduce myself. I am Aisha Choli, a high school graduate and currently a gap year student. As I said, I've started the organization last year. We have a team, or we are a team of 5, and three of us are here in the meeting. Two of us couldn't join. Two of our team members couldn't join, but other two members are here. So I would love to introduce them as well. And yeah, so firstly we have Abhishek as Nair. He's from Thrissur, Kerala, India, and he is an electrical and electronics engineering student, hardware designer, project hobbyist, and a tech expert in robotics and automation, drone technology, and avionics rocketry. He'll be working as a resource person or instructor for robots. He's actually the resource person of RoboVice. And we also have Neha Baju, who is the executive assistant of RoboVice. She's a student from Vidya Academy of Science and Technology. She had done her internship as the content writing intern for IEEE Kerala section. She has also secured many leadership positions in her college under her IEEE student branch. So I'm so happy to have both of them. And we have two other members too, who is Safwan Fazil and Joel Johnson. So Safwan is the digital marketing head, and Joel is our content head. Both of them couldn't join, I think. I can't see them, so they haven't joined. But we'll be introducing them maybe in our next few webinars. So I think we can go on to our session, but I can see someone saying my voice is low. So just a second, I'll just fix it. Am I audible now? Just let me know through the chat box. Yeah, okay. Thank you. Before starting the session with Sanjay Bangalore, before that, I would love to know about each one of you, where you're from, like your country of residence, and also just let me know where are you all from. Just send in the chat box your country of residence. Would love to know where you all have joined from. The country you are living in. Just send in the chat box. Okay. We have from Oman, I think we have the most participants from India, I think. And then through our registration, we have seen that most of them are from India, and then we have from Oman and from a few GCC countries as well. Happy to see you all respond. Thank you so much for responding. Okay, so mostly I think everyone are from India, and one has sent from Chennai in South India. Nice. Okay. Okay, nice. Great. So now, just if you're ready for our webinar, send a ready in the chat box. Send a ready now. And after that, we can go to the introduction of our speaker and we can start our webinar. So just send ready in the chat box now. Awesome. Thank you all for responding. So I think we can move on. Okay. Thank you all for responding. So everyone is ready. So let's begin with the session. Before that, let me introduce our speaker. Our speaker is Sankarshan Bangalore, also known as Shanky B, who is a roboticist who had been in the robotics industry for over 6+ years, developing several consumer and industrial robots. He is an alumni of the prestigious Manipal University. He has graduated Masters in Industrial Automation and Robotics. He is currently working at RoboVice. He is leading a team developing affordable warehouse and logistics robots for the Asian market. His expertise lies in robotics hardware and software development with a core focus on robotics product prototyping and development. His motto is be a full-time robot and a part-time human, which refers to how much hard work we need to put just like a robot and how we need to pursue our passion with humanity. Mentoring several students and guiding them to build a strong career in robotics, we at RoboVice are honored to have you for our today's session on Introduction to the World of Robotics. Over to you, sir.
Thank you so much. Thank you for the introduction. As you all heard, RoboVice is trying to create a community for robot enthusiasts. So that's why I'm willing to do anything for robotics. Over to the presentation. Yeah. So I hope you all can see my screen.
Yes.
Great. So welcome to the world of robotics, and it's a very cool concept and a cool idea and a cool industry to be in and be working in. And I have been working for around 6+ years in robotics and have almost met all the robots in the world. Yet to meet Sophia, the world humanoid robot. And welcome. And my name is Sankarshan. You can also call me Shanky. I go by the name Shanky or Shanky Robot. So that's what my social media handles are. Moving further, like based on this webinar, we'll understand what exactly is robotics and different fields of robotics. You'll get a general idea of what is happening in the world right now. So what is robotics? Robotics is basically a field of interacting multiple engineering industries and disciplines coming together to make machines that are automated. and you don't need to worry if the robot is doing correctly or not, or the robot might go on a strike or the robot is tired or needs lunch break. No, you just power it and it's working and it's doing the work continuously without getting tired. You can make robot do anything. There's limitless possibilities with robotics. It's making human life easier. It's making production faster. The new phones that you want to buy are all made by robots. The new cars that you want to buy is all built by robots. So there's endless possibilities. And as you can see in the video, there's robots that are playing music. This is by Nigel Stanford. He makes amazing videos. He's a PhD from Stanford University and makes amazing videos with a robot. This is a KUKA robot, which is playing guitar, which is playing different instruments, playing a drum. I'll share the video links later on to the group that we have created. Moving on to the disciplines to understand what exactly robotics actually entails. So in robotics, there's three area of interest or three engineering field that get involved very much. First is the mechanical, which deals with the kinematics, dynamics. You don't need to understand those words. It's basically dealing with the physical entity or physical world. Mechanics is what touches the reality. So it deals with the real hardware stuff of the robots and how the robot should look like or how the robot should feel like, and also how the robot should move like. So this is what mechanical engineering deals in robotics. Next comes in the electrical and electronics engineering, which deals with both the power system. So you need batteries or powers to make the robot move. Like we have food to eat, and that's why we walk around. Otherwise, we'll all be tired and cannot walk around. So that's what electrical deals with the power systems of the robotic systems. Electronic deals with two things. One is sensors, other one is the brain, controllers. So the sensor senses the reality, converts it into a language the robot can understand, just like human beings. So if the coffee is hot or coffee is cold, you'll get to know by touching it. So you're sensing the hot and cold. That's what sensors do. And then your brain processes that, thinking, oh, it's hot, it's too hot to touch, so don't touch. If it's too cold to drink, I want to heat it up again. So that's what a robot also tries to do. It tries to sense things, and the microcontroller or the controller basically processes like a brain and tells what is the answer it should give. Next deals with computer science engineering. Computer science deals with the whole IT aspects of robotics. You do programming and tell the brain or the controller saying, okay, this is what you need to do, and this is how you should do it. So you give a set of instructions saying, okay, go there, pick up the coffee cup, heat it up, bring it to me. So that's what instructions you give in programming language. So robot understands programming language, and that's what computer science deals with. So computer science side deals with like software application. You can sit anywhere and do computer science work on robotics, but for electrical or electronics and mechanical, you need to be there with the robot to build it up. In basic field of application, like you understood, like there's three different fields of engineering. There's three different application field of application as well. First is a hardware application, where you deal with the physical work, you deal with the specification the robot should have, the shape, and what application the robot can do. If you have a robot that is in the shape of a ball and just rolls around, and that's a job of the robot, you cannot ask that robot saying, hey, pick up the cup of coffee. The robot will be like, I don't have arms, how will I pick it up? So that's what hardware application deals with. You design the robot, you work with the robot, you create a robot, you create the physical structure to do the job. Next is the software application, where you program the robot what it should do. The software also deals with two aspects. One is programming the robot on what robot should do, and second is a simulation. So you don't need to build a physical robot technically altogether at first, because it will take too much money, too much time to get parts, and right now there's chip shortage, so you cannot get all the parts together, assemble it together, and by the time you have assembled and made it, you might have run hundreds and thousands of simulations online. So that's what a software application also does. It's reducing the time that it takes to create robots. The third application or field of application is the most commonly one and most commonly entertained by robotics is hardware and software. So a robotics engineer basically knows what the hardware in robot is and what the software in robotics is used. So this is where it all combines in, and you create a whole system of robotics. And with robotics, you add internet to it, and it becomes a whole system of robotics IoT. So this is one of the example of a pick and place robot. So it is a company called Yaskawa, and it's doing a work of picking up marbles and placing it into designated areas. On the left side, you can see there's a calculator like object. It's not actually a calculator, it's basically the programmer. It's called teach pendant or key pendant. What you can do is put a set of instructions saying, okay, you pick a marble from there and place it there. So it will keep on looking and checking if the marble is present or not, and if it is present, it will pick it up and place it there. Now it also needs to have instruction on how it should pick. So it should go like this or like this. So you give clear and precise and clean instructions to a robot so it functions clearly and correctly. You're all wondering what applications or what field of areas robotics would be in, right? So there's different applications there. These are the application sectors. First is the industrial robotics, which entails a big umbrella under which there are several industries that use robotics. In the main core focus of industrial robotics is to automate the whole processes, whole production line, so that you don't need human interference again and again. So a human should not go and check if the part is correct or not, if the robot is doing work correctly or not. So that's what whole automating system works in. And the best part about it is, like, if you automate a whole industry, you don't need lights, you don't need fans, you don't need air conditioning, you don't need to check if the robot is feeling comfortable or not, if the robot needs sweater or not in cold weather. So robot will keep on functioning. It doesn't care. You just have programmed it, it will keep on working. That makes process smoother, clear, and more efficient and effective. That is what industrial robotics are used for. So there's a whole assembly line and it's automated. You just put in the raw materials, the robot will pick up what they have to do. Some robot has to do paint job, some robot has to do assembly, some robot has to solder electronics on the chips, PCBs. So that will all be taken care of by robots. Next comes in domestic robots, and domestic robots are very cool aspects because robots are not only accessible to the industries or people working in big factories. No, 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 no. There are domestic robots as well. Have you seen the vacuum cleaning robot? So there's a vacuum cleaning robot called as Roomba, which will, you just have to put it on the floor. It has sensors mounted on it. It has its own brain. It will keep on vacuum cleaning and cleaning your floors again and again, and whatever time you set in. So you just have to tell what time you want your floors clean. It will go and clean the floors. You don't have to bother with mopping or sweeping the whole day, or like, okay, wondering, oh, guests are coming, so I need to clean again. No, just tell the robot, it will do the job for you. Then another small domestic robots, which technically can be called as a robot, is smart speakers like Alexa and Google Home. So these are basically small speakers and have artificial intelligence built into it. So if you ask any questions, they will reply. For example, Alexa, what's the current time? So so it takes care. So you just have to ask questions and it will reply. This is how artificial intelligence also changing, and robots are being accessible to domestic works as well. There's dishwashing robot, there's cooking robots as well. So there's robotic arm that goes, cuts all the vegetables, makes food, makes amazing dishes. So these are all domestic robots. There's also medical robots. In medical robots, again, there is two aspects of it. First is medical assistive robot. In medical assistive robot, it's basically robots. Those are assisting people. There might be patient who is unable to walk and wants to get down from bed to the wheelchair to go somewhere, or to go to toilet, or maybe go to CT scan or something. So this assistive robot will carefully lift the patient up, place it on the wheelchair, and will also push the wheelchair. There's also smart wheelchairs also available, which will literally lift you out of the bed, will convert into a wheelchair, and will move according to what its designated area is. And then the next cool thing is there's surgical robots as well. So this robots performing surgery, and it's not actually the robot sitting in. There's obviously a doctor behind who has done several years of study and is expert in his field. Otherwise, you don't want robot poking into your, internal organs. So that's what a surgical robot does. I'll also show you a video of a cool grape surgery. So a grape is being sutured. So I'll show the video as well. There's military robotics as well. So there's different military equipments done for surveillance, done for different activities and tasks. So it's saving human life, also doing surveillance activities to prevent any human life to go away. So this is what military robotics is also dealing with. There's also hobby robotics, which I'm greatly involved in. Hobby robotics are robots that are built in small scale and can be made into a bigger scale and bigger industry. So people who do hobby robotics are called makers, developers, tinkerers. So this is where hobby robotics takes a role from small scale to the larger industry. And all these sectors where the applications of robotics are all started from hobby robotics. So people who start doing hobby robotics end up doing bigger things in life. Here is a video of warehouse robotics. This is in Amazon. So this is when you order something online and you check, okay, you want something delivered. So this robot will go to the rack and it will scan the barcodes of what all things are there. If you have ordered, let's say, shampoo, and you want shampoo to be delivered, it will go to the rack that needs to be delivered. And then it will take to a location where those particular pin codes that need to be delivered are taken care of. And as you can see, there are so many robots working together so many times because there's so many people ordering stuff at a time, right? So if you just check in the whole area, 1 kilometer area, how many people have ordered right now, you might find thousands of people ordering something or the other. And this needs to be done. This is a logistics application which is taken care of with warehouse robotics. And there are sensors so that it does not collide into something and there's no missing parts. How many times have you lost something with Amazon? Rarely, right? So this is why, because there's less human interaction and more robot interaction. And you can have faith with robot. So that's what robotics is taking care of. There's also something called as cobot, which is called collaborative robot. These are robots that are working with human beings. They're not doing heavy major stuff that, okay, a human cannot stand beside it. But if it has complete safety features, which will help a robot do work slowly, move slowly, and can interact with a human being. Just like this guy, he's working with a robot. If you go to an industry where big robots are placed, you cannot enter the space. And if you do, you will be flung away like a cricket ball. So that's what safety place takes in picture, and why that's why cobots are also built. So you have an assembly line where a human interaction is needed. So human does something complicated which a robot cannot perform, and then they give it back to robot and then tell, okay, do this, do that. Yeah. So there's military robotics as well. So there's different tanks and everything that are built autonomously and made so mechanical that, okay, you don't have to bother sitting in and going somewhere. You just have a remote control and you can go anywhere that you want. You can do surveillance activity, you can do defense activities. So it's protected, you're protecting the civilians and you're moving anywhere, and it's taken care of completely by robotics. So these are the surveillance robot. There's also places where people are affected due to wars and they need some food or the first aid delivered. So these robotics also plays a role where these are bomb proof and won't get damaged so easily. And there's no people sitting and driving the car. There's a person who is far, far away, probably thousands of kilometers away, driving it with a remote and is delivering things that people require. So this is where robotics also takes over in the field of surveillance activities as well as military robotics. So this is a video I was talking about the surgery of a grape. So they have peeled off a skin of a grape. Grape is this tiny and it's trying to suture it back. And this is controlled by a doctor who is sitting away, probably thousands of kilometers away. And he's controlling it with joysticks and the pins that they have control a key teleoperation basically. And what they do is the surgeon performs very clean operation. And this so safety feature is that if the surgeon sneezes, and if he's doing actual surgery, that's a bad thing, right? You don't want like something poking like that when someone sneezes. So what happens is that there's like jerk protection, there's protection where if there's movement that is happening very fast, the robot does the processing, the brain of the robot does the processing, and the robot moves slowly as much as possible and doing clean work. As you can see, the surgery of the grape is happening very successfully. I hope the grape is doing very well right now and has good recovery. Moving on to the next application sectors. So there is applications of robots in space. People, instead of people being sent to space and wondering, okay, will they come back or when will they be gone, and saying hi, they're using robots. Like robots can do much better and can stay in space for longer. There's so many applications like ISRO, NASA, and several other companies, SpaceX, they're building robots that can go in space and do space exploration. That's what we are trying to find out, where it all started, what is there in other planets. Can we live on another planet, and can we make a house in another planet? There's even plots that are sold on Moon and Mars right now. So it's endless possibilities, and robot is making it happen. There's also food related robotics. So food related robotics is always in in the food processing industries. So if you want cheese, you want some food that is very clean and hygienic, a robot will do a better job. You don't want someone's hair falling over your food and getting it packed, right? So it's bad and gross. So robots are pretty clean in that sense. And you'll get food that is very well processed and is even. So if you take a packet of Lays or Coca-Cola and you taste it, the taste that you have tasted on the first day will be the same in the next year as well, and the year coming next. So that's how it maintains a stable output or the quality of the food evenly. There's also agriculture robots that are doing very well in growing agricultural food and also making things easier for farmers, because there's so big land and he has to drag all the harvesting, all the sowing seed, there's watering, irrigation, pest control, so much things that's going in agriculture. So robots are taking over and are making things easier for farmers. So farmer just has to tell the robot what it should do. He can just sit and relax and the robot will get the job done, and he'll be happy because things are happening, things are working. And food, there's a lot of food shortage happening, and agriculture robots will prevent more food loss and will keep on more cultivation can happen. There's also finance technology. Like finance technology is completely out of these all engineering fields. These are all like something technical, has machineries in it. But have you thought robotics and finance? Like it's accounting. You take an Excel sheet, you take a calculator and do, right? You can never understand why would finance also have robotics. But finance sector also has robotics built in it. There's artificial intelligence that is doing predictive analysis of what, when the stock would go high, when the stock would go low, what NFT could be sold, what blockchain can be tapped to, and what is the market happening right now. So this is how AI in robotics is also taking over there. You have so many apps like IQ option, stock option, and you can go and check, okay, what would be the possible returns that I'll get in this particular stock. It's doing calculation of several data that it has fed into. There's also mining robots, where robots so small are sent into spaces where, okay, human cannot go because it's a hazardous environment and you want safety. Robotics is mainly based for safety of human being. And mining robots are robots because they're sent into small spaces where there might be less oxygen under there. There would be toxic gases, even hazardous gases as well. It could blow up. So these mining robots go into these tiny spaces and try to, mine precious metals, minerals, whatever is possible. Sometimes mining robots are also used for finding artifacts. So archaeology also uses this mining robots, and they want to see, okay, I can find dinosaur bone, or they can find some mummies. So I don't know about daddies, but they do find a lot of mummies. So that's what mining robot does. So here is an example of space robotic that NASA is doing. And NASA is preparing quite a lot of robots for doing space exploration. It's both manned and unmanned motion, but they're planning more for unmanned work, basically. Sending a person to space and calling them back is very expensive, and it's very scary and hazardous as well. But if you are sending a robot, you don't have to bother for it to come back. You're like, go, it's okay, we'll build a new one. So that's what is happening with NASA. They're building so many robots, they're sending into space. And due to NASA's development in space technology, this is possible. Driverless car is possible because of NASA's technology built on robotics. So Tesla building a driverless car, or other companies that are building driverless cars, it's because NASA's technology, where they have added sensors so the robot can move autonomously without any instruction to be given like beforehand. It just needs sensor data, and it will keep on moving and will keep on going, and you can sit easily and comfortably in a driverless car. There's also robotics in agriculture, like I said. So there's farm tractors. There's something called as weeds that grow around the plants. So these basically takes on the fertilizer and nutrients that the plant should actually need. And it's like basically the weeds are basically eating the food out of someone else's plate. You want tomatoes to be growing there, but someone else or some other plant is basically taking the nutrition from them. So it's hurting quite a lot, and it's not making it grow better, and maybe you have weak crop at the end, or probably smaller tomatoes, who knows. So it's these are the robots that are trying to kill all the using artificial intelligence and computer vision system. So it's using camera and checking which is a plant that it actually needs, and which are the bad plants that are growing in. So it just goes and targets that specific plants and kills it. And initially they were using the pesticides or the herbicides would be sprayed all over, which would also kill some of the weaker plants that were growing in, which was bad. In the end, the production quality or the quantity was low. Here, because it is targeted to those bad particular plants, the overall yield of crops are really, really good. And not all your plants are sprayed with toxic chemicals, and you get like clear, clean, good output yield out of it. This is also one of the cool robot that's there. It is an entertainment robot. Here is a toy robot, and it can dance, it can sing, it can do cool motions. These are like robots that are built to teach kids, to make play with kids, as well as talk and communicate with kids. So imagine having a robot at your home where your kid is learning from robot directly. Instead of me teaching, it would be a robot teaching in the future. So that's a possibility with robotics here. As you can see, there's so many motions that a robot is doing. All you saw was industrial robot or farming robot, space robots. This is a humanoid, tiny humanoid robot. It looks like a human. It dances pretty much like a human. Michael Jackson would be very happy looking at this. So that's what robotics is. It's endless possibilities. Now going to logistics, there's something called as warehouse robotics, where your material is being shipped from one place to another place. There's two type of warehouse robotics. It's one is internal, so you get the raw material and where it should be sent internally. So some parts need to be like cleaned, some parts needs to be washed, some parts needs to be painted, some parts needs to be assembled. So these are all what internal warehouse robots does. This is what Amazon is doing in their internal warehouse, where they are trying to locate where they have kept the material, and then they are trying to make it so that it's shipped to the correct location in the end. There's also a bigger scale warehouse robotics, which is sending it externally. They're carrying out the logistics. Like there is driverless car, there's driverless shipment, there's driverless aeroplanes as well. You just put things on autopilot and you can sit and relax, and it will reach the destination very carefully and very precisely. So you don't have to worry about it. This is what robotics is doing. And initially you had to wait quite a lot of days. Like if you order something online, you had to wait probably like 15 days, 30 days, sometimes even 3 months just to get something. Now Amazon warehouse has done so much implementation with robotics that you can order something and it will be delivered next day. There's also possibility it will be delivered the same day itself. So this is what warehouse robotics is doing. There's also cloud robotics. Cloud robotics is technically not a hardware robotic, it is a software based robotic systems. So here what you're doing is controlling robots via the cloud, which means via the internet. Cloud basically means the internet and a storage device. So you don't have to worry and think, oh, it's clouds in the sky can control robots. No, it cannot. You have to connect it via the internet, and you can control robot that could be sitting, like let's say you're in India and you want to control a robot in US. You can sit here and control the robot in US. Currently, as of now, I'm doing work on robotics that is actually being controlled by USA. There's a robot in India right now in Delhi. The company name is Orangewood. You can check it out. There's several videos online as well. So the people are sitting in USA are controlling robot that is sitting in India, and you can see it doing motions that they want to do. This is how cloud robotics is taking over and making things easier for work from home applications as well. So you're sitting working from home, you can control a robot from home. Why bother going to office, right? And there's also simulation robotics. Simulation robotics deals with creating a robot or making a robot move in a way that robot has never moved in. So this is what simulation is happening. And simulation is very, very important when you're trying to create a new robot. First, you take a design and you create a CAD model or 3D model out of it, and you'd use that 3D model to simulate the motion that is possible. And then you check if it can do the work or not. If it cannot, you change the design again, and then you do. So you have not spent any money as of now, but you're just trying and simulating and checking it out if that robot can do the work or not. If the robot can do the work, then you can just order parts what exactly you require. So customize part as instant as possible just with simulation. There's also something called as process automation. So there's a word called as RPA, which you might be hearing quite a lot, which is robot process automation. Robot process automation is doing data analysis of several processed and unprocessed data and is trying to control and automate it. So example for this would be Instagram. Suppose you want to share some photos and you have a folder filled with photos. You create an Excel sheet, you type in what taglines you want, what hashtags you want, hashtag cool, hashtag trek, or something like that. And then you create a whole data set. Now, you don't know, you have to sit every day, click, add in all the files, add in all the taglines, add in the hashtag, tag someone on the photo. So it takes a lot of time just to put one photo. What you can do is use this process automation. Take a folder, put it in. Take the Excel sheet, put it in. Robot will understand what it has to do. You just have to tell him, link it with this Instagram profile. It will keep on updating and posting a lot of photos as you have scheduled it. If you want it scheduled like 7 p.m. at night, or 7 a.m. in the morning, or 3 a.m. at night, so whatever is possible, you can just automate this process. This is just one tiny example. You can process automate a robotic system as well. So if the robot is doing some other work and you want it to do some other work, you can just schedule it to a situation where it can do other work as well. So it would be like, tightening a bottle cap, and the next application you should do is sealing chip packets. You can do that with process automation. Then there is automobile robotics, which is driverless car and manufacturing of those cars. So robotics have taken over automobile industries, where now cars are driverless. They are basically the robot where you can chill, sit, relax. You just have to enter the destination. It will take you to the destination. You will reach safely. It will avoid as many accidents as possible, will not break any traffic laws, which is very, very important. That's why it's very difficult to get driverless cars in India. Like, nobody follows the traffic law. So the car that you will build, which will be a driverless car, has to break some rules just to be able to drive in India. That's why automobile robotics is also taking over. It's a joke. Don't take any offense over it. So here is the example of internal warehouse robots, where robots are given a particular path. So it's a fixed path. They have drawn certain black lines over it. It's a magnetic strip, and the robot is moving, and it's taking parts and materials that are required from containers which are delivered to it. It will take that and will deliver to the station that it is required. So if there's electronic parts, it goes and takes it and delivers it to the electronics engineer. If there is a mechanical part, it goes and delivers to mechanical engineer. If there is some fabric, it takes it and delivers to the tailors. So it could be anything. You can have different materials, and the robot will go pick it up. As you can see, it's picking up the boxes and it's taking to the designated area. Magnetic strip, that's bottom at the below, like as you can see this black line shining. So this is what the track is. It will not go away from the track. It will keep on following the track, and it has sensors mounted on it, so that if someone is standing in front of it or walking through, it will stop completely and will wait till the person has completely moved in. This is what is happening in warehouse robotics. Here is one of the hobby robotics. Basically, this is robotics that is built to navigate into terrains which are not nearly possible. So, off-road, there's off-road like this. So there's like weird steps that are kept in, and the robot has track tires with different mechanism that is put over it. So the robot can navigate and move in this particular terrain, and it's doing all the work of mapping. On the left side, the colorful diagram that you see is what the sensors are mapping the whole area, and they're taking note of what the terrain is like. This is what robot is doing. It's taking the map, and once you have the map, you know which path to take to go where. If you didn't have Google Map, you would be asking everyone, hey, where to go, where is this temple, or where is this place, where is this hotel, or where is this location. Basically, once you have a map, you have stopped asking questions to a lot of people. You just open the phone, you check the map. Oh, it's somewhere here. You go in, and if you don't find it, if like in worst cases scenario, then you go and ask someone if where's the location. Basically, this is what a robot is helping in doing. So Google have also mounted several robots, several cameras, and taking street photos, mapping the area, mapping the places which even you did not know was just beside your house. Okay, there was a hotel here, or there was a grocery stand there, so you do not know, but because of all the mapping that's happening, you can find things out. This is what robot is capable of. And it's also showing the capability of a robot moving in a different terrain. It's not just flat surfaces, it can move into weird structure, weird terrains as well. And last applications of robotics is dance. It's basically, this is a company called Boston Dynamics, which has made amazing robots and has made amazing development in the field of robotics. The white robot that you can see, those are dancing like a human being, is called Atlas. This small yellow robot is called the Spot. The big robot that came in is called Stretch. So these are the robots that Boston Dynamics has built. And this is not a CGI video. This is literally the actual dance video that was taken and programmed to the robot so the robot can do the dance. And you can check this out on YouTube. There's several videos like this. They're dancing differently and are making cool motions. So it's a fun company, and it's one of the toppest, most R&D based robotics company. So, well, RoboVice basically contacted me for this webinar, and I was very happy and glad to do so because it was about engaging with the community. It's trying to build community for beginners and for robot enthusiasts. Being a robot enthusiast myself, I'm very happy to join this community. It's about engaging with the community. And here is the website. You can go and check it out. And the tagline is an organization by beginners for beginners. And if you have any questions, I'm open for questions now. There are no stupid questions that you should remember. So you can ask any questions you want. You can send it in the chat box. I can read it out.
Yeah, you can send it in the chat box. And thank you so much, Shanky. Thank you so much. It was a very informative session, I feel, because when we think about robots, the only thing that come in our mind is like the humanoid robots, right? We think that robots are only physical robots, but there are also robots used on software level, right? So many doesn't know that. So I think it'll be a new information to many that how it's being used in various fields. So we actually have a question. What is an IoT, Internet of Things?
Okay. Okay. IoT basically is Internet of Thing. And here Internet of Thing is defined as anything that is connected to internet and is sharing data. So best example would be a smartwatch. So your smartwatch connects to your phone and uses internet through your phone. And the smartwatch is collecting data like how many steps you have moved, have you completed the steps for the day, what is your heart rate, what is your blood pressure, what is your sugar levels. So these are all the data that the smartwatch is taking in, and it's sharing with the internet. And internet would be like on your own platform. So if you check the app on your phone, like how many steps you have walked in, it will let you know. So that's what an IoT is. Anything can be connected to a internet. You can have smart toothbrush. So if you brush your teeth, how many times you have brushed your teeth, or like have you brushed the teeth properly or not, and have you used the brush for the given amount of time or not. So that's what IoT deals with. The second part where IoT deals with also security of data. So if you're using smart toothbrush and the data is shared to everyone, that would be bad, right? If you have not brushed the teeth today and people are staying away because they know that you have not brushed the teeth. So that's what security is also a part of IoT. And it just means anything that can be connected to internet can be called as a thing of IoT.
Yeah, exactly. And many of our devices in the future now itself are actually connected to internet, and we will be able to like track where the device is. Like we think, like for example, when we lose our specs somewhere, we're like, where the hell is the specs? If we could have a mobile phone to just miss call and see where the specs was, where this device was. But now with Internet of Things, we can actually track where our device is actually, even if we miss them. Like as Shanky said, we have the smart watches which can actually detect our heart rate, our all those things health related, and then even those details can be sent to a doctor via cloud, and then it's amazing, right? How even our health, it is actually, there are actually a lot of advantages to internet of things, and it's an amazing field under robotics, and a field that many can pursue definitely. And I think we have Meghna sent something. We could ask Google to know where our specs is. IoT is amazing. Yeah, IoT is amazing, definitely.
Yeah, it is amazing. Like Apple has built something called as AirTag, which is small chip that you can connect with your phone, and you can place it on something. You can place it on a keychain. You can place it on your specs. You can place it on toothbrush or bag. And if you have lost it or it's gone somewhere, you can just open the app and it will, tag it, okay, where it might be. Is it 20 feet away? Is it 10 feet away? It will open up a map that will show, okay, where exactly these things are. So that's what IoT is doing. Google is also trying to do that, but Apple has been successfully done that.
Yeah. Great. So next question is, are there any disadvantages of using robots?
Okay,
Question that
like
comes
there are,
always, right?
this is a really good question. The thing is, robotics is good, but too much robotics is not good. What robotics is also doing is taking over jobs, which might be considered like a low level or a hard labor job. So it's taking over jobs of people because of automation, and it's the truth. You cannot run away from the truth, and that's what happened. That is one of the biggest disadvantage of using a robot. And second is the power consumption, because it's robot and it uses electricity, and we're using like thermal or coal and hydroelectric solar panels. These are all expensive machineries that is needed. Even like a lot of fuel are being burned just to generate electricity. So these are the two major disadvantage of robotics. There might be more depending on the application that you're doing. So if there's a vacuum cleaner robot, it might have some advantage, some disadvantage. You want it to run a carpet, it won't clean the carpet, but it can only clean the floor. So it's disadvantage in sense of applications as well.
Yeah, sure. What we need to work towards is actually how to, solve those small issues, right? The small problems, definitely. And one interesting question that I got personally was, Sophia said she will, assassinate humans in future. How can we even believe this? One question I've got direct
Can you
message.
repeat the question?
So she, I think she had asked Sophia the robot, right?
Yeah.
She said that she would kill humans in future. So how can we even believe this?
Like she won't be able to do that. It's just a joke that the programmers had programmed in. Like right now, like the time that she was saying, she only had motors till her neck, so that's what she would be able to do, and move the face expression. Like if you tell her to stand, she wouldn't be able to stand. So what could a head do? And now probably she's getting legs and she can walk around. It's still a far away future where she can try and assassinate. And robots are built with metals, right? So they are heavy machinery and they require a lot of battery, and they're all electrical system. So if a robot is chasing you down and it's trying to kill you, just throw some water over it. It will short circuit and die.
And then even we have the very basic laws, Isaac Asimov's laws of robotics, right? Don't harm anyone.
If you have only programmed it, then only it will be applicable. If you have not programmed it, it won't be applicable. That's what. So they're like core fundamental things that robotics or robotics engineer usually follows. Is like if there's military robotics, there's always someone sitting behind the robot and controlling the robot. So someone has to be held accountable for any mishap that happens. So it cannot be like the robot has done like hands up. No, there has to be someone accountable. So these are one of the core laws. Asimov laws is also one of the core laws for robotics, which takes over and like, okay, you have to follow this no matter what. One of the question by Jane is programming language needed for robotics. So there's two major programming language used heavily in robotics. One is C++ and second one is Python. So these two are heavily used in robotics. There's also a middleware called as ROS, Robotic Operating System. It's not an operating system like Windows or Ubuntu. It's just a middleware. You can program and simulate robotics there as well. You can use both C++ and Python there. So these are the core programming languages. And another question is, are artificial limbs a type of robot? So it depends. If the limb can think on itself, do things on itself, it can be considered a part of robotics, but not completely robotics. So it's somewhere in between there. Like it's a thing that has to be discussed and brainstorm thinking, okay, can we consider this as a robot or not? So if it's not functioning according to its own, then you cannot call it as a robot. Robot will think for itself. And another one, how is robotics helping in EV industry? So electrical vehicle industry, robotics is taking care of a lot of things in electronic vehicle, like electric vehicle industry. where it's doing the assembly work. There's also something called as hardware in loop system, where you're connecting hardwares, that it could be batteries that is used in electric, there could be chips, and it's doing the testing application as well. So it can test if the battery is correct or not, is suitable for using it in the vehicle or not. It's doing several test runs over the batteries, and once the batteries are passed, then only it gets installed in the car. Otherwise, batteries are not known to be very safe, because we have seen phone blowing up, we have seen cars blowing up. So robotics is helping, taking care of a lot of test runs. Otherwise, a human would be sitting with a multimeter or some tool and lab bench power supply and oscilloscope, and tweaking it. So this is where robotics also taking over. There's also robotic algorithms that can be put inside an electric vehicle, that can do all this data analysis that is there. Whatever data that the car is sending, it can analyze, process the data, and will understand if the battery is correct or not, or if the age of the battery, okay, something, there's a possibility that, okay, the battery might be dying. So it sends the data to the server or the company which the car is produced in, and tell, okay, the battery needs replacement, so send it as soon as possible. So it prevents breakdown from happening, which is predictive analysis right there. Then there
And
is
one question was sent to me personally, saying every house can't have robots. I think she mentioned about, like, financially maybe every house cannot have robots. But I think one thing I would think is that, like, just like we have mobile phones, right? In the future, it might be that we have robots. Everyone has robots in our houses, right?
yes, that is correct. So it's a possibility, like because electronics are getting cheaper and cheaper and smaller. There was a time when the phone was as big as a brick. People were carrying phone as big as a brick and talking over it, and the hand would pain because it's a brick. So everything has become smaller and
Even the
smaller, and
computers, right? Even the
yes, and
computers
also
were in a
cheaper.
huge room, and then
Hmm.
we we
Yes,
have it small now. Just like even a phone, right? It's like a
yes,
mini
mini
computer.
computer. Yes,
Yeah.
definitely.
Where are you?
And have you answered this question? Are artificial limbs a type of robot?
Yeah, so that's what the question is. Like, it could be called as a robot if it's working on its own, but it requires a human support. So you cannot technically call it as a robot. You can call it as a prosthetics, not a robot in that sense.
It's like an assistance, right, to people with disability and
Yes,
all.
yes. There's another question by Eileen. AI and robotics are at times used in same sentence in multiple places, but are they different? Yes, they're definitely different. AI is completely software-based system, which is doing the processing work. AI means artificial intelligence. Before we reach to artificial intelligence, you are basically take any robot or take a software, let's say, and the software is it does the calculate. It's a calculator. Let's take calculator as an example. What you teach a calculator is how to do calculations. So it can do plus, minus, subtraction, division, addition, everything. But now you're adding in data that okay, this is what it needs to do calculation on. Let's say accounting, you have data of everyone's salary in the company, let's say, and you want to do tally everything out. So you give that and you make a robot understand and make it realize what it needs to do. So it's learning on how to do things, like a baby is learning to do things. Now the robot or the system is trying to learn how to do things. Once it has learned what to do and how to do, it becomes an artificial intelligence system. So you don't have to tell it and teach it again. Once you have taught it, it has learned. And once it has learned, it has become artificial intelligence. It's like giving intelligence something that did not have intelligence to. And robotics, AI comes under the umbrella of robotics. AI, IoT, ML. So these are all umbrella under the robotic system. So you can call it
And
separate.
I have got one question in direct message. Robots are awesome, but in future, if there are more robots used in manufacturing, etc., won't there be, like, she's asking, won't there be like unemployment will rise, right? And there will be jobs for robots, but not for people. So how would you like to answer that?
Okay. This is a very interesting question, and I like that this question was asked. So what I meant was robot taking away the job. It would take away the job that is repetitive. Best example for that, this would be ticket counter. So what do you do in a ticket counter? Let's say like you are buying ticket for train or metro. You go to the counter, you pay the money, you tell the station, they give you the ticket for that particular station. And that person sitting there is doing that job for the whole day. There's another person coming in for the night shift. is sitting there and doing the same thing again and again. Are they doing something intelligent? Definitely not. What extra skill does a person need to do this particular job? So robots are taking away the job that are literally boring and does not require human intelligence as much as it's need to be. So what it's doing is taking away menial job in such way that these are all boring jobs. So this is not using human capability to its fullest. After robot takes over such jobs, you will have more jobs in fields where it would be required, like you'll use your brain a lot. Now programming field, there's no programmers just like 50 years, or not just 50 years, just 20 years back, there were not so many programmers in the world. Now like everyone is a software engineer, software developer right there. Nobody had expected that this could be a possibility, but it took over, and it's taking over because humans are built for artistic as well as logical thinking and some creativity altogether. They're not built to do same thing again and again. There's also analogy of like tightening a nut and bolt. So if the job of a person every day is just tightening the nut and bolt again and again the whole day for his whole life, what has he achieved? I'm not saying that it's a bad thing to do that job, because it's getting money for him and his family, right? So right now it's doing that, but if he's given the opportunity to grow further, to learn further, and build better and smarter career where his potential is used to his fullest. So that's what robotics is also trying to do in this sense. There's another question with by Anas. What is ML and AI to do with robotics? Okay, ML is basically machine learning. AI is artificial intelligence. Machine learning is teaching the robot what it should do and how it should do. So you're teaching, let's take a robot for example, and you're teaching the robot what it should do. If it has to dance, then you show it how to dance. Once you have taught it how to dance, let's say you have played the song, let's say baby shark do, 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 and once it hears the song, it has to do the dance. That's what you have taught it. If you're playing any other song, it will not dance, but once you play the song baby shark do, 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 it will start dancing. That's what you have given it, intelligence, where it hears any particular song that is it's trained to do or it is learned to do, it becomes an artificial intelligence system. So the machine will keep on learning, and once it has learned everything that it has to learn, it will become artificial intelligence in the robotic system. There's another question
So
by
AI,
Rangola.
AI is more like already programmed, whereas ML is teaching, right, after programming.
Yes, in most cases it is, but AI and ML usually work hand in hand. So there are separate applications for separate ML and separate AI as well. But in most cases, AI and ML work together. Even with the case of like Google assistants like Alexa and Google Home, like once you keep on talking, it will keep on recognizing your voice. And even if you're sleepy and drowsy and you're woken up and you're like, Alexa, tell me something or something, like it will literally recognize your voice. Like you can ask like, who am I? It will tell you who you are. So that's what AI and ML are working together. It's trying to build better machines, a better algorithm, and trying to create a data set that can be collectively called as intelligence.
Another question is robots can't work independently without man control, isn't it? So just it's like a doubt. Okay. Yes or no.
So okay, there are different type of robots as well. There's manned robots where a robot needs to have someone to control it continuously. Then there is independent autonomous robots, which is automatic. You have to program it once. Its only job is to do something repeatedly. It has to pick something from here, place it here. Once you have programmed it and it has to do this pick and place, it's done. You just have to walk away. You can sleep or you can go home. Doesn't matter. You have programmed it for the robot to do its job. It will keep on doing the job independently. The only drawback for this is you have to do a continuous monitoring, and you have to put something called as ID. If the robot breaks down, then you need to know that robot has broken down or something has gone bad. So that's what you have to monitor. You don't have to monitor anything else. You don't have to monitor any control if it's doing correctly or not. It will do correctly because you have made it do correctly.
Yes. Other questions over?
There are a few more questions actually, but yeah, if there's more questions, you can follow, you can join the WhatsApp group, and you can also follow on LinkedIn and social media, Instagram and YouTube profiles. There's also Discord server, I think. Discord, right?
Yeah, we'll be sharing it in the WhatsApp group.
So yeah, so Discord community that is created, you can ask questions there. I'll answer as much as possible. And
can we take one more question, and I think we can
sure.
end with the last question Meghna has asked. Another example of an ML is YouTube personalizes itself for each user and suggests videos. So
that is correct. That is ML and AI working together.
we'll be sending the Discord details in the WhatsApp group. I'll send the link for the WhatsApp group so that you all can join. And then are the questions over, Shanki?
There were few. I think I've lost them. 1 second. There's one question by Rangola. Robots are emotionally thinking or not? Why? Okay. Emotions are very complicated chemical reaction that goes in brain, and it's very difficult to make it into mathematical models saying, okay, this is what happiness is, this is what sadness is, or this is what love is, this is what anger is. Till the time you cannot create emotions into mathematical language, you cannot give emotions to a robot. That's where like it is stuck. So if you can, create a mathematical equation of this, exactly this is the mathematical equation that this is feeling, and now you can use that math to train the robot to become emotional robot. And taking care of emotional robot would be slightly a pain. You don't want to do that, right? Then it will start going on strikes, and you don't want that as well. And there's another question by Sayed Salman Ahmed. Why do we implement artificial intelligence in robots? So we implement it to make it better, make it run smoother and faster. So there's always some or the other problems with mechanical structure. Like a car, the engine is too noisy, or maybe it's taking on too much fuel, or the battery capacity is low, it's not working correctly, it's not going as fast as it should. So this is where artificial intelligence like keeps on learning with ML, and then creates algorithm and takes the data set of what it should know and makes it perform more efficiently and effectively. So this is why AI plays a key role.
And one question about humanoid robotics, as the name suggests, it's robots that look like and act like humans, right? Not exactly. Yes. I think it's mostly the movements, right? Movements of
Humanoid
humans,
robots
right?
are basically robots that look, that the white robot that you can see in the back, they are like robot that has hands, legs, has body. So it looks like a human and can do some motions like a human. That's why it is called a humanoid robot. This yellow robot is a dog like robot, so it's based on animal but it's not based on human being. So that's why the name is Spot. Spot is a very common dog name.
Yeah.
I think we are done.
Yeah, we are done. Thank you so much. Thank you for joining. The way you said it so passionately, you have taken it, and with so much, and in between you're using humor as well. I loved it. Loved the way you took the session, and I didn't expect these many questions. Mashallah, so many questions were there, and I think we were able to help at least small amount of students at least. I'm so happy about it. And this is our first webinar. We can have more webinars together, right, Shanki?
Yes, definitely.
Yeah, thank you so much, everyone, for joining. And I have actually sent a feedback form here. We are giving e-certificate of participation for everyone who joined. So you can, you can fill this form. And then after filling, just within a few seconds, you'll get an email with your certificate of participation. So once again, thank you so much all for joining. And thank you, Shanki, for such a beautiful explanation and clearing all of our doubts. So I think we can wind up.